We have mostly so far been using standard form. Please copy these 3 forms down. Please be very careful that you copy them down accurately. We have been mostly using standard form. But when you're graphing, which we're going to be working on now, vertex form is actually easier form to graph from. And then we have also done some root form, because root form is the same thing as a factored form. How do you think you get to a factored form? You would need to factor. So today we're mainly going to be looking at vertex form. And when you're looking at vertex form, it's focusing on the vertex. So when you're in vertex form, it focuses on the vertex. And this is vertex form. And if the A is positive, the vertex opens up. If A is negative, the vertex opens down. The point HK is the vertex. That's why we call it vertex form. And to find more points on the graph, you pick points and substitute them into the equation. So take a minute and write this down. This first example is in standard form. Standard form, once again, is A parentheses x minus h squared plus k. Where am I going to find the A? In front of the parentheses. But in my first example, did you write this problem down on your paper? In my first example, do I have a number in front of the parentheses? So what's the A? If there's no number written in front of the parentheses, the A is 1. Is 1 positive? Then that means that when I graph this in a minute, the graph is going to open up. And I need the vertex point. This is called vertex form because I can easily find the vertex point. There's the vertex point. Except for one thing. Because there's a negative in the formula, to get this to be a positive, it had to be minus a minus to make a positive. If this is positive 2 in the formula, this is negative 2. You have to remember, you have to memorize that x is a liar. If it says positive 2, this is the x number because it's in parentheses with the x. But if it says positive 2, the vertex is actually negative 2. This number over here is not a liar. If it says negative 1, it is negative 1. That is my vertex point. Now, from our lesson the other day, we have the graph that's opening up. We have the vertex point. By the way, if the vertex point is there, is that a maximum or a minimum? Minimum. Where is this axis of symmetry? No, where is it in my little sketch here? Goes right down the middle. The axis of symmetry is the line down the middle that divides it in half, 2 equal halves. Did my axis of symmetry go through the vertex point? Because it is a vertical line, it has an undefined slope, you can't write it as y equals mx plus b. Vertical lines have the equation x equals a number. Which one of those is an x number? So the axis of symmetry is x equals -2. That is the equation for this line. How are we going to find a y-intercept? How do we do that? Here is our equation. Anytime to find the y-intercept, you substitute a 0 in place of x to find the y-intercept. It doesn't matter what kind of equation, whether it's a linear equation or a quadratic equation or a cubic equation or an exponential equation or any kind of equation. To find the y-intercept, you substitute in place of x a 0. So what is this? 0 plus 2 is? 2 squared is? And then you have the -1, and what's 4 minus 1? So my y-intercept is 0, 3. We'll do the domain and the range in just a minute when we draw the graph, because that's what we're going to be doing next. Well, in order to draw the graph, we need more points. So we're going to make a table, and we're going to find more points, and we're going to put the vertex point in the middle of the table. So make you a little table on your paper and put the vertex point in the middle. We want the vertex point in the middle because we want the points that are close to the vertex point. Because if it's not fairly close to the vertex point, the numbers are going to be so big they're going to go off my graph anyway. So this would be -4, -3, -2, -1, 0. Well, we already know what 0 is. We figured it out right there. 0 goes with 3. We figured it out right there. My original equation is, and I am going to substitute in place of the x, I'm going to substitute in a -4 to find this point right here. What is -4 plus 2? Well, actually -2, and -2 squared is going to be, -2 times -2 is going to make the 4 minus 1. This is also going to be equal to 3. And so now I'm going to plug in a -3 in place of x, and I'm going to calculate. This is going to be equal to -1, and when I square it, I would get +1, subtract this 1. What's 1 subtract 1? Can I fit one more on there? In place of the x, I'm going to substitute in this -1. This is equal to +1, and square it. 1 squared is still 1. This one is that -1 right there, and so this one's also came out to be 0. So I fill in the table by plugging points into the original equation. Then, on your paper, make an XY axis. And what was the first point on the table? -4 and what? 1, 2, 3, 4. 1, 2, 3. You're just going to make a sketch as accurately as you can. And what? -3 and what? Was it -3 and 0? Who has a table? -3 and 0. And 2 and -1. And so you put those points that we just figured out in the table, you put those on your graph paper. And do you see the parabola taking shape? And so the parabola, do you see that the parabola is going to open up just like we said just a minute ago? So are your points taking shape? Now, you see that I put arrows on the top? Because it's going up and up and up. And as it goes up and up and up, it also spreads out to the left and the right. How far is it going to spread out to the left and the right? This is going to be all real numbers. You can put the fancy looking R, or you can write out the words all real numbers, going back and writing down your domain and range. What about the range? Nope. Well, that may be a way to say it. That's not how I would say it. So it goes here and it goes up, right? Range is how far down, how far up? Does it keep going down forever and ever and ever, or does it have a bottom point? Where is the bottom point? What is the y value of the bottom point? So it's going to be greater than or equal to -1. And so we have one last thing to do to this problem. This is the problem we've just been working on. And it's in what kind of form? That's called vertex form. How do we get it to standard form? Standard form is what we have been using most of the time so far. How do we get it in standard form? In standard form, do you see any parentheses? So the first thing I need to do is multiply that out so that it doesn't have any parentheses. And so I prefer to multiply it out with a box problem. You can multiply it out other ways. And then you combine like terms. And so this would be f of x equals x squared plus 2x plus 4. Now that's not the answer, because this is equal to that. What else do I have? -1. It's almost finished. So in standard form, this would be x squared plus 2x plus 3. That's in standard form. What in standard form, what's the c in this right here? Is that your c? What is your y-intercept? 0, 3? You think there's a connection? Probably so if I pointed it out, right? Okay, let's look at a second example. You're going to write down the vertex form. And we're going to figure out the graph. The first thing we're going to figure out about the graph is, does the graph open up or does it open down? And that depends on the A in the vertex form. So what is the A? Not just negative, but the A is equal to -1. We usually don't write the 1 in front of the parentheses. The A is equal to -1. So is it going to open up or down? The vertex comes from those two numbers, except x is a liar. If it says +3, the vertex is really -3. This one's not a liar, just that one. The axis of symmetry goes through the vertex. The axis of symmetry is going to be x equals the x part of the vertex. To find the y-intercept, in the original equation, you replace the x with 0, and you calculate it out. Now, what do we have in parentheses? 0 plus 3 is 3, and then 3 gets squared. So this is 9. This negative sign is out in front of the parentheses. This is the 3 squared, and the negative sign out in front of the parentheses makes that a negative. And so this would be equal to -5. The intercept is 0, -5. And then to make a graph, we need some additional points. So to make a graph, we need additional points. So in our table, we're going to put the vertex point in the middle of our table, because we're going to need to find points close to the vertex. If it's not close to the vertex, it's going to be so big it's going to go off of our graph, probably. So this is going to be -5, -4, -3, -2, -1. And so we are going to write down our original equation, and in place of x, in place of the x, we're going to put a -5. I had something else inside that parentheses. So this is going to be this negative sign, and we're going to have a +4. And inside the parentheses, that's going to be a -2. And a -2 times a -2 is a +4. And this negative is the negative out in front of the parentheses. So what's -4 plus 4? Now, remember this has an axis of symmetry? What does axis of symmetry mean? If you cut it in half, the two halves match. If you cut it in half, where? At the vertex? It's going to go through the vertex. This is where the axis of symmetry is. Because of symmetry, if this one is 0, that one's 0 also. Or you could figure it out again if you want to. But if I had a -1 here, this would be a positive 2 squared, and you would get the exact same answer. Because I'm running out of space here, I'm just going to erase this. Instead, I don't have room to write a whole different one. What's my next number right here? I'm going to put in a negative 4. What's this going to be equal to? That would be a negative 1, and when you square a negative 1, what do you get? Negative 1 times negative 1 is, and so that would be a 3. If this is a 3, this will also be a 3, because it has to be symmetric around, what's this point right here? So now let's put those points on the graph. 1, 2, 3, 4, 5. Negative 5 and 0. 1, 2, 3, 4, 1, 2, 3. Okay, and then negative 3. Do you see the parabola pointing down? The domain on the parabola is always going to be all real numbers. But the range is not. It's pointing down, so the range is going to be y less than or equal to, what is the y value of this number right here? And so there was another point, though, that I can put on my graph. So what was the y-intercept on my graph? Wasn't it negative 5? And then because of symmetry, I would have one over here also. And so I could also put my y-intercept on my graph and make an even better graph. I suppose pretend it went through that dot right there. Just make the dot bigger. So, one final thing. How can I take this vertex form and make it into standard form? Standard form doesn't have any parentheses. So the first thing I'm going to need to do is multiply that out so it doesn't have any parentheses. And so, see this negative sign right here? This negative sign is out in front of this parentheses. When you add that together, this is what you get. When you multiply this out, that's what you get, but there's a negative sign out in front and a plus 4 out in back. What am I going to do with that negative sign out in front? Distribute the negatives. Combine like terms. Compare this number right here to the number you wrote down for the y-intercept. What do you notice about that number? That number is the y-intercept. One more example. Open up or open down? A is equal to 1. If there's no number written in front of the parentheses, the A is written is 1. Can you tell me the vertex? The vertex are these two numbers right here, but what are you going to remember about the 1? X is a liar. If it says -1, the vertex is actually +1. The axis of symmetry has to go through the vertex. To find the y-intercept, you plug in 0 in place of the x. In the original equation, in place of x, you put 0. So that would be -1 squared minus 8. -1 times -1 is +1. And so this number right here is now what? In order to graph it, I need some points. Is it a good idea just to pick random points and throw them in my table? No, you want to put your vertex point in the middle of your table. And you'll let me make a mistake. What's my mistake? What's a stupid mistake? What's the original equation? If you write down the equation wrong, are you going to get the right answer? This should have been a 9. And so this should be, so it is important for you to copy the equation down right. So this number right here, this was supposed to be the original equation. When I copied it from here to here, I miscopied it. So if you have that wrong in your notes, please fix it. And so we already figured this one out right here. We know what this one is equal to. Hold on, I still got it wrong. I put that in the wrong place. That one was right. I needed to start all over. Okay. And this one was where the -8 should have gone. And this one is 0, -8, and this one is 1, -9. And because of symmetry, if this is -8, this one's -8. So it makes your table smarter, easier to figure out if you use symmetry. Now, let's see if I can do it correctly this time. Copy down the original equation. And in place of the x, I'm going to put this -1 in place of x and figure it out. And so, what is -1 minus 1? And what is -2 squared? And so this is a -5, and then because of symmetry, That one will be a minus 5. Okay, y'all don't let me make a multiplication or subtraction mistake this time. Anybody see any mistakes? We're good? Okay, then we're ready to graph it. By the way, we would have caught that mistake on this screen right here because it wouldn't have made a parabola. So what was our first point? Negative 1, 1, 2, 3, 4, 5. And 0 and negative 8. Which way is this supposed to be? I didn't go far. Okay. 0 and negative 8. Five, 6, 7, 8. And then 9. And then 8. And of course, this will be easier with graph paper. And so this is our parabola. The domain is all real numbers. It is going up, so the range is y greater than the y value right here. What's the y value right here? By the way, this y value right here, is it a maximum or a minimum? It's a minimum because it's at the bottom.